R&W designs and produces a wide variety of backlash-free ball detent safety couplings, offering precision torque overload protection and preventing equipment damage and downtime in the event of a machine malfunction. Due in part to a patented internal preload and a special spring characteristic, R&W safety couplings are often capable of reacting much more quickly and accurately than electronic controls in preventing mechanical overloads. Here we'll be covering how they work, available configurations, adjustment of the disengagement torque setting, and handling of fully disengaging types. R&W safety couplings start with a precision machined clutch base and a series of hardened steel drive balls. The balls are retained in an array of holes around the perimeter of the clutch base and braced on one side by a machined ring. Situated between two rows of ball bearings is an output flange with conical detents to fit over the drive balls. The outer row of bearings is covered by a retaining ring and held in place by a snap ring. One or more disc springs are placed against the ring, which braces the drive balls on the other side, and pressed against the ring by a spanner nut, which threads onto the clutch base. Finally, a means of locking the safety coupling to a shaft is included, which in this case is shown as a clamping bushing. The output flange is fitted with either a flexible shaft coupling or another drive connection device, such as a gear, roller chain sprocket, or timing belt sprocket. Under normal conditions, the assembly stays locked together to transmit motion and torque with zero backlash. When an overload occurs, the conical detents of the output flange push the drive balls out against the spring plate, causing the drive line to disengage. A proximity sensor is often used to detect the actuation and signal the control unit to stop the machine. One of the key components in R&W safety couplings is the disc or Belleville spring. Use of this spring not only lends itself to making the safety coupling more compact, but more importantly, it facilitates a faster disengagement than if traditional coil springs were to be used. This is because the springs function in the digressive range, where the spring provides decreasing resistance the more it is flattened, or the